producer consumer problem with semaphores, right? So the general statement about the producer consumer means producer will produce the items and consumer will consume the items by sharing a common memory called buffer, by sharing a common memory called buffer, right? So when you are trying to implement this particular problem, earlier cases we have seen the code for produce consumer to define data inconsistency. Later we have discussed same producer consumer problem to define busy waiting solution, synchronization mechanism implementation for the busy waiting solution. Later we have discussed the same problem producer consumer with respect to without busy waiting solution. Now we'll try to define the same problem to define with respect to the semaphores concept, right? So why we came to the semaphores concept? There is a drawback in the without busy waiting solutions. What is that? Here you are going to wastage unwanted wake up calls. That's the reason we introduced the concept of semaphores, where we are going to take some problem, some variable, right? So you can just revise the previous class so that you can get the clear idea. So let me try to write the code so that you can get the clear idea. I will take semaphore mutex equal to 1, semaphore empty equal to n, semaphore full equal to 0, and I am trying to write the code for producer. Void producer is not taking anything as a parameter. I am trying to take the what item is producer is producing character item. That is what we are trying to take from the starting of the classes, and I am going to make the process like producing the items in an infinite loop while of 1. I will try to perform wait of empty and wait of mutex, and I am going to perform inserting the data later. Inserting the data means we can take as buffer of n equal to item p, what is produced by the producer, and I will increment the value n equal to n plus 1. I can make it as mod n. Why I made this as mod n? Because if I take the buffer size as some 8 or some 16 or whatever it might be, 0, 1, 2, 3, 4, 5, 6, 7, total size is 8. When it reaches to the maximum value, next where it has to insert from the 0 onward. That's why I have taken here as n plus 1 mod n. So these two is meant for to insert the data and to define which location it has to be inserted. Later I will try to perform signal of mutex and then signal of full, and I am going to close the producer code. Then we'll go with the consumer. Consumer will consume the data which is not taking any parameter, and what item I am trying to take will be stored in a variable called char item c while of 1. I am going to perform wait of full, wait of mutex, item c equal to buffer of out. So hope you remembered the earlier class, right? So where in is a variable which is going to meant for to insert the tracking location where I want to insert. Out is a variable from which location I want to get the data. Right? That is what buffer of out means, the respective location that I am going to store in the item C. Then out equal to out plus 1 mod n, then signal of mutex, signal of empty. So this is the code to define the producer consumer problem with respect to the semaphores concept. Okay, fine. So what is going to be happen and how it will be executed? Right? Let us try to analyze it. So you know, semaphore means what? It's a kind of a procedure where you are going to use the variables concept, right? So generally mutex means I can call it as a binary semaphore whose value can be either 0 or 1, basically used for the purpose of mutual exclusion. Right? So which means that mutex is a variable. Mutex is a variable. Initially it contains the 0. Sorry. Initially it is initialized with what value? 1. If it decrements it, the process allowed to enter into the critical section. Can I go for again decrement? No. If it is less than 0, I won't allow into the critical section. I cannot able to increment more than one value also. Similarly, which means that I can say this is a kind of a binary semaphore, which is meant for the purpose of achieving what? Mutual exclusion, right? Similarly, I have taken one more variable called empty, which is of type what? Semaphore, whose value is initialized to what value? N. So empty is a variable which is a semaphore variable, right? So whose value I have made initialized with, let us take the initialization value as something like 3, which means that generally which will note down how many empty slots are there, which will define how many empty slots are there, that will be defined by empty semaphore variable, right? So in this particular case, for example, if I say x, y, z, k, l, that's it. How many empty slots are there here now? 3, that's why empty has 3. And generally full is a variable which is meant for to maintain total number of slots full so far. Total number of slots full so far will be defined by full variable, right? But when it is at the initialization process, the full will be generally 0. Now what is the full size? The full size is 5, right? Hope you understood the initialization logics. Now assume that what might be the cases for when the producer is idle. What might be the case for to make the producer idle? I can say it as, buffer is full? That is general logic, right? When buffer is full and consumer is not at all consuming anything, what producer has to do? Producer has to wait continuously, right? I can say that producer is idle, or I can say that buffer is full. If this case, will this case satisfy this code or not? Just check it, right? I will make the code line number 1, 2, and this is 3 and 4. 1, 2, 3 and 4, right? So when the buffer full is case, I can assume the mutex value as 1, means nobody using the buffer so far. And how many empty slots are there when the buffer is full? 0. And how many full slots are there when the buffer is full? N. Generally assume that my buffer of size 3, whose values are x, y, z, right? Now assume here somebody got the chance, either consumer get the chance or producer get the chance. Assume that buffer like producer got the chance. If producer got the chance, it is going to execute the line number 1. When it is executing the line number 1, what is the code they mentioned here? Weight of empty. Weight of empty means what? On empty variable, they has to decrement its value by 1. When decrement its value by 1, what is happened? -1, which is less than 0. So I won't allow to execute it. I won't allow to execute, right? If you remember the clearly counting binary semaphore concept, you will get the clear idea, right? So when the value is negative, I won't allow for the execution, which means that I am going to completely waiting at this particular state. Means when the buffer is full, is the producer is able to produce items according to the code? No. That's why this logic is perfectly working, right? Similarly, can I take another case? Consumer might be idle. Consumer might be idle. When the consumer is might be idle, when the consumer is buffer is empty. Buffer is going to be empty. When the buffer is going to be empty, for example, consumer got the chance and executing the line number 1. Weight of full. So what is the condition for the consumer idle? Mutex value is 1 anyhow. Empty will be how many? Empty will be full. Empty will be 3 n. And what are full? What is the value of full? 0. Total number of items in the buffer is 0 now, and total empty starts are what? 3. Now consumer is executing the chance. When the consumer is executing chance, is there any items are there? No. Means is the weight of full. What is weight of full? Weight of full is what? 0, which led to -1. -1 is not allowed. So consumer is going to be in the iteration process itself here, which means that the consumer idle satisfying condition is satisfying or not? Yes. Like this particular code is going to work. Now take out the random case where producer and consumer are working parallel, right? So the case something like mutex, empty value 3, full value is 5, which means total empty starts are 3, total full starts are 5. Now suppose for example, consumer got the chance. Consumer is executing the line number 1. When consumer is executing the line number 1, what might be the situation? Weight of full. Consumer code. Weight of full. Weight of full means what? It will decrement by 1, which is not less than 0. So allow for further step execution. So line number 2 is going to be executed. Weight of mutex. Or else, okay, let me go with weight of mutex. Weight of mutex means what? It will be decremented with 0, 1, so which is not less than 0. So allow for further execution. Means now, can it enter into critical section? Yes. And then parallelly, preemption happen and producer got the chance. When producer got a chance, it is going to perform what? Weight of empty. It is going to produce weight of empty. Does it allow? Yes or no? Yes. So decrement by 1, that is 2, and it is performing line number 2. Weight of mutex. Now it will work? No. Means I have taken the permission, but I should not allow to enter into the critical section because there is already a consumer is consuming the data which is in the critical section, right? That's why here it is not going to allow for you to access the critical section as this value is -1. This value is -1. So this way it will work. Now definitely after a certain point of time, consumer again got the chance and consumer will execute the line number 3 and line number 4. Execute the line number 3 and line number 4. When execute the line number 3 and line number 4, signal of mutex means 1, signal of empty 3. Is it okay? Signal means what? Increment the value by 1. which means that now how many empty spaces are there now? 3 empty spaces are. That is what the meaning of this one. So done. Now definitely now producer got the chance. When producer got the chance, will it execute the line number 2 now? Yes. What is that? Weight of mutex, which means decrement 1 by 0, and it will move its process. Like this, this producer consumer problem is going to work for you. Right? So you might think that, sir, is this the only solution? No. You might execute in variety of ways. First producer got a chance. In this particular case, I got the consumer got a chance, but it might give a chance to producer also. Depending upon the chances, how the scheduler will give the chance to execute, the way in which this order of instructions is going to be executed. Right? At any cost, you have to understood how the algorithm is going to work. In the gate also, they will give the code and they will ask for you to analyze which of the following is satisfying or not. Right? So in the previous class, I have taken problem on the gate, did a problem like related to mutex, and asked you to whether it is satisfying the mutual exclusion or not. Like that I have mentioned clearly. Right? So the same way they may ask, or some situations where they might ask for you if these two lines of code are interchanged. If these two lines of code are interchanged, what will happen? Which means that weight of mutex is the first line and the weight of empty is the second line, and the remaining code is as usual. Does it satisfy the entire producer consumer problem solution or not? That is what their question. Right? Now, can you analyze that? Right? So there will be one special case is there. There will be one special case is there. That special case is, this is the kind of thing. When the buffer is full. When the buffer is full. What is the case for buffer full? Generally, mutex will be 1 and empty spaces are 0 and full equal to 3. Right? This is general happens. Now, if these lines of code you mentioned in place of these two lines of code, suppose for example, if consumer got the chance, is it works fine? Yes, good. If consumer got the chance and will execute the line number 1 and assume that it is preempted, 2, decremented by 1, that is 2, and then producer got the chance to execute line number 1. Line number 1. What is the line number 1? Weight of mutex, that will be 0. That will be 0, right? Means 1 executed. 0, good. And suppose for example preempted. Now consumer got the chance to execute the line number 2. Line number 2 if it is executing, weight of what? Mutex means, is it allowed? No. Is it allowed? No. When it is not allowed, it is given chance to what? Second one, that is producer. Producer execute the second line. Weight of empty. Weight of empty means what? 0 decremented by minus 1, which is again suspended. It's again suspended. If you are going to clearly observe here, if you are going to execute any number of times, always the consumer is at the line number 2, producer at the line number 2, which is a kind of what? Deadlock. Right? So actually this problem won't occur if you have written the exact logic. But if the logic is changed in such a way that this is the modified one. If this is logic, if you change, then definitely you are going to get the deadlock. And all the remaining cases are going to execute perfectly for you. Okay, na?